Hey folks, I am back here now for the last and final slides of day 3. If Mr. Mullett deems it appropriate, you could definitely take a little break after this, and this is definitely, day 3 is the longest day of notes, so I apologize on that. But I just want to make sure I've covered it, so that when it comes to vocabulary, quizzes, and so forth, you are good to go. So, this is part 3 of day 3. Again, we saw the comparison between 1980 and 2015, big difference in the amount of ice at the Arctic. You're going to see it in your lifetime. I will be here with you when it happens, but Mr. Mullett can make sure he shows you these 2 YouTube videos. That would be awesome. All right, so the last 2 slides. Here we go. We have a topic. This one is for your notes. So, to your notebook, let's go with indirect versus direct light. Due to Earth's 23.5 tilt, during the summer, the northern hemisphere receives more direct rays, and during the winter, the northern hemisphere receives more indirect rays. The same light just spread over more land will be the thought process here. Same light spread over more land, and it causes a weaker light. Folks, go ahead and get your notes here. Mr. Mullett, if you could pause it, I appreciate it. Thank you for pausing it so students could get the information in here. This idea of indirect versus direct light, I might actually quote Mr. Tolkien of Lord of the Rings here. But I'm going to point out that, and of course there it is, that if we start thinking about it as butter, and the sunlight is the amount of butter, if I was to take butter and spread it over, let's see, a very, very small piece of bread, say a crouton, the flavor of the butter would be very, very strong. But if I was to go and say take a piece of French bread, and take that exact same piece of butter and cut the French bread the long way, so now I've got a lot of surface area, and I tried spreading that whole pat of butter across the piece of bread, the taste of the butter would be very, very weak. And so that definitely is, there's so many ways you could talk about this. Think about it from this standpoint. The sun's changing position. When it's June, the sun is more direct up in the sky, so you get a more direct ray. This is from Allentown, Pennsylvania, by the way. And as you get closer to the shortest day of the year, December 21st, the sun falls very, very low on the horizon as compared to June, where it seems to be more up in the sky. A nice way to think about that also, flashlights you can use. A flashlight produces a known surface area at 90 degrees straight at the surface, but as you turn the flashlight to 73, the surface area seems to grow, and as you turn it all the way to 26 degrees, the surface area grows even more. Now the flashlight hasn't changed in terms of its intensity. The surface area to which it hits, that has changed. It's spread out more. And so this would be more of a winter situation. This would be more of a summer situation. Direct versus indirect. Another way to phrase it, let's see here, short shadows versus long shadows. In the summertime, when you're standing outside, you're looking down, the sun's over your head, your shadow seems really, really short around noon. But do the exact same exercise on December 21st, the shortest day of the year, and stand outside, your shadow will be much longer because the sun is lower in the horizon. So, another way to view this idea. We don't need to get into this. It's just reinforcing the visual idea that there's low sun, low energy, high sun, high energy. It makes more sense if you view it this way. Please note, this would actually be a nice picture to put into my notes. It seems to be a piece of sunlight, a bit of sunlight is hitting, and the surface area is roughly the same between the 2 situations. This is summer, more direct sunlight. You can pause and draw this if you wish it. And when it comes to winter, here's the opposite. Same sunlight, same length as we saw during the summer, except now it's hitting a larger surface area. So here's your sunlight compared to your surface area. The light is spread over more surface area. Another way to think of it. Say I went and gave you a fancy ketchup packet. And I said, all right, you get 1 fancy ketchup packet and you get 1 French fry. Put the ketchup on the French fry. Lots of ketchup on the French fry. However, if I then gave you, oh, I don't know, a Five Guys pouch, Five Guys paper bag of French fries, and only one ketchup packet, and I told you to spread it out and deal, you'd hardly get any taste of ketchup at all. It's a nice way to kind of visualize it. The amount of energy has not changed in both situations. It's just how it gets spread out over surfaces. Direct versus indirect light. Cool. Last up here is our fronts and air masses, and I'm going to think that the last picture here might be in your way and you might not see it. So I'm going to ask everybody here in the classroom to go ahead and add this to your notes. Let's go and label it here as cold front, being what we see here. There it is. Cold front. Cold front is when cold moves under warm. A warm front is when warm moves over cooler. And a stationary front, obviously, is when you've got nothing happening. And a occluded front is when you've got a bunch of fronts occurring at once. And I'll explain these last two here in a moment. But take a moment, pause the video, and label your notes as fronts and air masses, and get this information here into your notes, please. Pause. Unpause. Okay, so what does this look like as far as pictures go? So we're going to talk about a cold front first. And notice, this is what it looks like on maps when you're looking at meteorological maps. But a cold front, here we go. So a cold front is when the cold air moves underneath a warm front. So it makes sense. The warm air is less dense and therefore would rise up above. Notice cold air right here. You got warm air that's moist and it's being chilled as it's pushed up. Great way to form nice heavy-duty thunderclouds. We always used to giggle and laugh in the summertime, but when you got those really hot, steamy days, and then all of a sudden a cold front comes through, you were guaranteed thunder and lightning that night. And that's true, because now this moisture is being sent up as well as being chilled, and you get that nice thundercloud effect. So there's your cold front. Here is a warm front. So again, we're moving from left to right. We've got warm air that's going to ride up on top of cold air. Now, the warm air always has more moisture than the cold air, and the warm air here seems to be pushed up higher and higher and higher to the point where the warm air, and this is what we've been lacking lately, folks, here in New England when it comes to snow days. We need that warm, moist air from the south to interact with the cold front from the north to go and drop all that tons of snow on, which we characteristically call a nor'easter. We just haven't had any of those, so hence the reason there's not a single bit of snow out there. So that's a warm front. Then, here's the stationary front. Please observe, the warm front moves from left to right, the cold front moves from right to left. No one's moving, the front is not moving back or forth, it's staying quote-unquote stationary. So this is what we call a stationary front. And this is the occluded front. Please note, you've got a cold front moving underneath another cold front, not by much, and a warm front stuck in the middle. It's called an occluded front. You're going to end up getting really sloppy, messy type of weather during one of these. I just think of those days in the spring and the fall where you get this kind of nasty, raw mix of weather and so forth. So that's usually an occluded front. All right, cool. And we don't need to talk about this one. All right, so that's all, folks. I mentioned this to you because at this point now, this is day 3 and we are done. Next up is tree period, so if you could pause the video, Mr. Mullett, I appreciate it. And tree period's next. All right. All right, tree period, day 3. Here's your deal. You're going to go and spend no time on your MCAS paperwork. You don't have a paperwork for today, but definitely your planners to start, SSR for 10 minutes. At some point, it might make sense, if not today or maybe tomorrow, to have Mr. Mullett take you down to the library to renew books. I don't know where people stand on things. I want to make sure that's taken care of. But no paperwork for today once you get your 10 minutes done. Instead, I want you to get right back into the island, the Michael Bay bomber, and enjoy this video filled with lots of action and so forth. Don't be freaked out. This video's got a little interesting twist. All right, you guys, have a good one. I'll talk to you tomorrow. Adios.